Hi, Dr. Cap. Travis White-Velez here with this week's Advanced Interactive Concept presentation. For this week's presentation, you will need hydrogen peroxide. You will need some dish soap. You will also need yeast, as well as some small plastic cups. And I'm going to be utilizing a mason jar or a water bottle for my reaction. Stay tuned, and I'm going to record the reaction, and hopefully it works out. And then after the reaction's all cleaned up, I will then explain why what happened during the reaction happened. And I also forgot to say, you will need food coloring as well. I was unable to find the potassium iodide, so it will just be the first of the reactions where the hydrogen peroxide and the yeast are utilized. Stay tuned, be right back. So now that I have the equipment that I need, I'm going to go ahead and do the experiment. I have a little warm water here. So before I get started, I'm just gonna put some baker's yeast inside of the warm water to activate it. Give it a good stir. All right. Here's the yeast, getting that all just stirred up and getting that activated in the warm water. Again, you don't want the water to be too cold and you don't want the water to be too hot. You kind of just want it right in the middle. So if you turn your tap all the way to the hot setting, that should be good unless your tap gets, scorching hot. Inside of the water bottle, I'm going to put hydrogen peroxide. We're going to fill it up a good amount. Let's say maybe we'll do a little more than half the container or half the water bottle or so. All right. A little more. And then from there, I'm gonna go ahead and put some of the dish soap. Can be pretty liberal with the dish soap. Give that a good little swirl. You don't want to create bubbles, you just kind of want to get it all mixed in there. And then I'm going to take my food coloring and we're going to put some of that inside the bottle, drip it onto the side. There we go. You'll see the food coloring start to change the water or the hydrogen peroxide. And then now I'm going to add the baker's yeast and we are going to watch what happens. All right, and as we can see, we have a pretty good reaction going on. And it continues to go. And while this is going on, I'm gonna go ahead and get this mess cleaned up. And then I will explain to you what took place in this experiment, why the reaction happened the way it did, and what components caused the reaction to react, and then what is also the limiting agent inside of this reaction. Stay tuned and I will be back. Okay, so now that that experiment is conducted, I will explain the reactions and what happened in the experiment. So the hydrogen peroxide is mixed with the yeast solution. A little bit about hydrogen peroxide: it's considered unstable on its own because it breaks down over time into water and oxygen. The yeast is a catalyst. It produces catalase, which when mixed with the hydrogen peroxide actually speeds up the breakdown or the removal of the oxygen and the oxygen, hydrogen, and water molecules. So it separates those bonds. So it leaves you with oxygen, hydrogen, and a water molecule. Those broken bonds happen so rapidly that they create heat because of the induced energy. And the oxygen that is broken away from the hydrogen peroxide is now trapped in the soap, which is where the foam comes from, or in this case, we call it the elephant toothpaste. So I hope I've done a good job at explaining that, and I hope this experiment helps someone understand endothermic reactions, or excuse me, exothermic reactions, because it's giving off heat, as well as what happens when you introduce a catalyst into a system to break a bond.